Okay, so hy het nie klaar, he didn't have an initial velocity. Hy het nie oorspronklike snelheid gehad nie. Sy initial velocity was 0 en nou word hierdie kragte op hom uitgeoefen en nou gaan hy begin beweeg. Hoe het ek dit geweet? Soos wat het vir my sin gemaak? Ek het gesien, maar luister hierso. These two forces can't cancel each other out. Hulle kan nie op mekaar uitkanselleer nie, want they are not, it's not the one to the right and the one to the left, so hulle is equal to one another. The one is at an angle, een is in 'n hoekie. En hulle sê ignore the effects of friction, beteken daar's geen wrywing wat nog een kan help of wat nie. Okay, so like die hele voorwerp kan nie nou nog in 'n rus wees. It can't be at rest anymore because these two forces do not cancel each other out. Okay. So daar gaan arbeid uitgeoefen word op die voorwerp. By the net force because the crate will. Okay, nou. As ek vinnig kyk, so I have a force to the left of 200. Wat is nou ander krag regs? Fx. En hoe gaan ek Fx gaan uitwerk?
300 cos.
Yes, because it will be the cos of 30. Nee, om x uit te werk. So, daai x gaan wees 200 cos van 30 grade. En ek sal dit vinnig uitwerk en jy kry dan 173,21. Okay, so you can see the force to the left is bigger than the force to the right. So wat gaan gebeur? Die voorwerp gaan links beweeg. It's going to accelerate to the left. Okay, so let's check. Lift it off the surface. Oopsie. Nee. Accelerate to the left. B. Yes. Okay. Is julle met my? Julle gaan my stop as julle 'n vraag het, né? Nee?
Maar ek was al ooit so 'n vraag van hy is van die oppervlak afloop ooit af wees.
Hierdie hoekie moet regtig baie groot wees. Verstaan, hy moet definitief groter as 60 grade wees om dit te kan doen. Of die krag moet regtig baie groot wees. Okay. Ja. Ja, die krag groot en die massa klein, dan kan dit doen. Okay. Dan sê hulle vir jou. The net force acting on an object is equal to the. Okay, so nou dis nou nie dieselfde vraag as hierbo nie. It's a new multiple choice question. The net force. Net force is equal to what again? Wat is die formule? M maal A. Is equal to the mass of the object. Dis nie net die massa van die voorwerp nie. The acceleration of the object. Dit is nie net versnelling nie. The change in momentum of an object. Change in momentum. Final minus initial. Is dit dieselfde as dit? Nee. Okay, so nee. Okay, so ons dink dit is D. We think it's D. Let's just check. The rate of change in momentum. Ugh. Rate of change. Dis die tempo van verandering. Wat is tempo nou weer? Right, is divided by time. So dis hierdie ding gedeel deur tyd. Kom ons check gou. The mass is the same. Massa is dieselfde, so kan die massa uithaal. What is the change in velocity over time? Versnelling. Nee? So this one is the correct one. Must I say again? Yes. Okay. Ek gaan net daai delete. Okay, so we have the rate of change, so that's divided by time, of momentum. So we have mv final minus mv initial divided by time. What I can do is I can take out the mass. Then I have final minus initial over time. And that is the same as saying the change in velocity over time, which is the same as acceleration. Okay. If there's time at the end left, we will start again at the multiple choice with Newton. Okay. Ag kom ons doen net gou vinnig sommer nommer 7. Terwyl dit so is. Kom ons doen 6 en 7, want 6 is ons lang terug gedoen. Which one of the following physical quantities, fisiese hoeveelhede, is the measure of inertia of a body? Inertia is traagheid. Okay. En dit het ek verduidelik in graad 11 aan die begin van die jaar. Dit was, ek dink meneer Milan was nog hierso. Toe sê ek in 'n rugbywedstryd, wie wil jy liewer tackle? Do you want to tackle me or do you want to tackle Mr. Milan? Hoekom? Explain it. So dit het te doen met my massa. The lighter you are, the easier it is to stop or to start an object. The heavier it is, more difficult. Okay, so inertia of traagheid het te doen met jou massa, jou mass.
Nou, ek het gelees in wetenskap, dit het oor traagheid.
Skip. So dit doen met massa. Okay, kom die volgende ene. The magnitude, die grootte of the gravitational force, gravitasiekrag, exerted by one body on another body is F. So daar is Newton se gravitasiewet. When the distance between the centers of the two bodies is doubled, so die afstand is nou 2 keer so groot, the magnitude of the gravitational force in terms of F will now be what? So dis is soos wat ons nou net gedoen het. But now the formula is just a bit different. R squared. Nou verander dit na F2. G, M1, M2 over. And they say there, the distance is doubled. Okay? So dit is nou 2R kwadraat. Is dit reg? Wat's fout?
Die 2 moet ook gekwadreer word.
Yes, die 2 moet ook gekwadreer word. 2 must also be squared. So dit is nou G, M1, M2 oor 4R kwadraat. Okay. So now what are we going to do? We're going to take out that 4. It becomes a quarter. Want is 1 op 4. 1 over 4. 1 over 4. En daai business, like soos daai business daar. So it's a quarter F. Kwart F. So die antwoord is A.
Ja, weet jy wat jy met 'n wat jy met kaarte vergelyk?
Hoe bedoel jy?
So as hulle sê die afstand hulle wat dit in terme van F, maar dit kan of 'n 4F wees of dit kan 'n kwart F wees, naam wat se opsig nooit kyk.
Nee, so daai F is mos die eerste scenario se F.
So vergelyk die eerste met die tweede.
Yes.
Ek doen as basis die eerste en figures kort vir daai en dit wil sê daai moet 'n kwart wees.
Yes. Okay, nou jou kop moet jy vir jouself sê, die afstand is verder van mekaar af, so die krag gaan kleiner wees. So moet 'n kleiner antwoord hê. Okay. Right, bing bing bing, bing bing bing. Tjoh, baie Newton vra. Vertical motion. Okay, let's say that. A stone is dropped from the edge of a cliff. Dropped, not thrown, nie gegooi nie, laat val. So dit sê vir jou, die beginsnelheid is 0. Which one of the graphs best represents a change in kinetic energy of the stone during its fall? The change in kinetic... Genigtig, wil hulle nou nie nog moeiliker maak nie. Okay, change in kinetic energy. Kom ons dink gou. What was the kinetic energy there at the beginning? No. Nee? So ons moet by 0 begin. Okay, so immediately B and D is gone because it doesn't start at 0. Okay. Nou is dit 'n eksponensiële grafiek of is dit 'n reguit lyn grafiek? Kom ons kyk gou na die formule vir kinetiese energie. Kinetiese energie is 1/2 mv². Sê julle vir my, watter tipe grafiek is dit? Exponential. Reguit lyn grafiek is y is gelyk aan mx plus c. There's no square or anything in that. Okay, so die antwoord is A. Want die snelheid gaan eksponensieel meer word. Of vermeerder word. Okay, next one there. It says, stone is thrown vertically upwards. So hy word opgegooi and returns to the thrower's hand after a while. Okay, so gaan op en terug. Which one of the following position versus time? So posisie, teenoor tydgrafieke verteenwoordig die beweging van die bal. Okay. Kom ons check net gou hoekom nie A nie. You can see it doesn't end where it started. So definitief nie A nie. Okay? Hoekom nie D nie? Want it goes down and up. Dit maak nie vir ons lekker sin nie. So it's between B and C. Okay? If it was a ja. Where is my puppy? Ja. Dankie. Okay. So hoekom nie? Wag, ek was besig om te sê as dit was 'n velocity versus time graph, 'n snelheid teenoor tyd grafiek, then you expect straight lines. Not necessarily like this. Die reguit lyne sou gewees het. Ja, die reguit lyne sou so gewees het actually. Okay, but it's not that, it's a position versus time graph. So in a position versus time graph, the gradient is not constant. Even.
Sou D gewerk het vir positiwiteit grafiek as die bal na die boog opgegooi word 'n dak tref en dan ja.
Nee, want hierdie se gradiënt verteenwoordig sy snelheid, is die gradiënt. En die bal gaan mos nou vinnig op en gaan hulle stadiger, vinniger. So hierso is die snelheid die hele tyd dieselfde. Dit is as jy konstant vorentoe ry, baie dankie, en konstant agtertoe ry. Okay. Kom ons kyk net gou een wat nie 'n prentjie is nie. Kom ons kyk by 3. Ag nee, 'n grafiek is nie. A person dived from a high platform into a pool. At which one of the positions, A, B, C, D, will the magnitude, die grootte, of his momentum be at a maximum? The magnitude, so nie die grootte, nie die rigting nie, grootte van sy momentum 'n maksimum wees. Wag, moenie antwoord nie. Ons check net gou. Momentum is massa maal snelheid. Okay, so his mass is the same everywhere, né? So it's independent, ja, it's independent on mass, is dependent on velocity. Alright. So ons wil kyk waar gaan sy snelheid die grootste wees. Can you imagine waar gaan hy bollemakkie sê in die water? What is the velocity there at sea? No. Okay, so definitely not C. Okay. So ek weet nie eers hoe om sê sonder die antwoorde sê nie. Let's compare D with A. Okay. Sê nou maar hy gaan hier op met 'n snelheid van 10. Let's say it's 10 meters per second. Then there it will also be 10 but negative 10. En dan gaan gravitasie gaan hom nog meer vinniger laat gaan. Gravity will make him go faster. So there at A, just before it hits the water, its velocity will be the greatest. Nee? So daarom is die antwoord by A.
Ek dink dit is 'n A en B, want ek of A is half in die water.
Nee, nog nie in nie, net voor die water. Okay, kom ons gaan na die volgende chapter toe. Jog, nee, het ek nou al verkeerde hoofstuk. Daar begin. Okay. Goed, dit sê daar vir jou. Ek dink hierdie was in julle praktika, hierdie vraag. Dink ek, nee? A boy mass 2m and a girl mass m are facing each other on roller skates. With their hands, they push off one another. The boy experiences a force F and acceleration A to the left. Okay, goed. So julle kan almal imagine, pa verlief en stoot en daar gat hulle nou. Which one of the following best describes the magnitude is grootte, of the force, die krag, and the acceleration, versnelling, experienced by the girl. Ignore the effects of friction, geen wrijving. Okay, dus hier is twee goed in play. Newton's laws en momentum. Die twee druk mekaar weg. En die krag wat die seun ervaar, the force that the boy experience, is F. What does Newton's third law say? Okay, so the magnitude, die grootte van die krag wat die meisie ervaar, moet F wees. It must be F because it's the same force, because it is the same contact point. Okay, so it moet wees either B B of C? Wat, dit is nie nog nie, of dit is nie 'n vraag nie, but if it was a question, as die seuns se verandering in momentum, if the boys change in momentum is B, what will the girls change in momentum be?
Want sy massa is
Ook B. Want die som van die momentum aan die begin moet gelyk wees aan die som van die momentum aan die einde. So the two momentums must cancel each other out. Hulle moet dieselfde wees. Dit was julle vraag aan die praktika. Okay. Dit was nou nie vraag hier nie, but the two change in momentums must be the same. Okay, but the acceleration, the velocity is not the same.
Dit is vir jou, die grootte van momentum is die momentum dieselfde. So
Ja.
die som is dieselfde maar die momentum.
Ja, die afsonderlike momentum. Okay. Right. So, for the boy, we have F is equal to M times A. Nee? A is the acceleration. What was it now? A is the acceleration, F is the force. For the meisie, for the girl, we know the force is going to be the same. The mass of the girl is what? M. The mass of the boy is 2m. Sien jy met my? Ja? So can I just fill in m here? Nee, want ek het nou net hier by die seun gesê, dis m. So what will the mass of the girl then be? A half m. Okay? So a half m, and we want to know what is this acceleration. So I'm going to call it A2. Okay. So ek wil A2 op sy eie kry, so I need to take this to the other side. Okay, so if I take that to the other side, dan word dit 2 F over M. Is jy reg? So? Okay, juffrou, dit help my nou aan absoluut niks. Nee, I must just get this equal to A. Okay, as ek hierdie gelyk kry aan A, then what did I do with M? I divided by M. So dis F gedeel deur M. So kom ons check gou. F divided by M is A. F divided by M is A. So dit is 2A. So daarom is dit daai antwoord. So my answer is B. Kom ek kyk gou of dit vir my logies sin maak. Maak dit vir my sin dat die meisie wat die helfte die massa van die seun is, 2 keer so vinnig gaan. Yes, it does make sense. Because it's... There we go. Okay. Kom ons kyk gaan na die volgende ene. A car of mass M moves along a straight line with a velocity of magnitude V. The driver sees an obstruction and immediately applies the brakes. Okay. The car stops uniformly. Uniformly is uniform. It beteken net. Uniformly just means the acceleration is constant. It's not -3, then -2, then -1, just deal with that negative whatever. Uniformly in t seconds from the moment that the brakes are applied. The car does not hit the obstruction. Okay. Which one of the following represents the magnitude, die grootte, of the average force, die gemiddelde krag, exerted on the car during the braking period of t seconds? Okay. So, hulle sê ja, het M, het V, het 'n krag. Nee, hulle wil weet wat is die krag? En jy het T sekondes. Watter formule kom in jou kop as jy hoor F, M, T? Impulse formula. Okay? What is the impulse formula? Oopsie daisy. Okay, but juffrou, ek sien nie 'n P daar ergens nie. Ons weet wat dit is. We know that F delta T is mv minus mv. Okay. But it says the car stops and it doesn't hit the obstruction, so the final velocity is 0. Nee, so jy het basically ft is gelyk aan minus m mal v, because this one is 0. So dan is die krag F is gelyk aan minus mv oor t. Juffrou, daar's nie 'n minus nie. Wat sê hulle? Which is the magnitude, net die grootte. So niks te doen met rigting nie. So that negative is obsolete vir ons worry nie daaroor nie. So dan is die antwoord C. Kyk, kan julle sien ek begin met formules altyd. Dit is wat multiple choice doen is. Kan jy met formules speel? Okay. Waar is dit nou? So. Okay. So energie, dryving, krag. An object moving at a constant velocity v has a kinetic energy E. Okay? The velocity is changed to 2v. Which one of the following is the correct kinetic energy at this velocity? Okay, velocity is snelheid. Okay, so hulle sê vir jou aan die begin, wag ek net beteken. Aan die begin het jy net gehad EK is like an a half mv squared, want the object was, I don't know, the mass and the velocity was v. Nou verander die snelheid na 2v. So nou het ek die kinetiese energie 2 is a half m, the mass didn't change of the object, maar nou die snelheid is 2v kwadraat. Is dit reg? No, because the whole 2v must be squared. So dit is nou a half m 4v kwadraat. Okay, nou moet jy versigtig wees. You must be careful. Because the initial velocity is half mv squared. So jy wil nie daai half gaan haal met daai 4 nie. Okay, because then you lose that half in what is kinetic energy. So jy gaan sê daai is, my plek is min. Jy gaan sê dis 4 half mv kwadraat. And that is the same as that. So it is 4e. So die antwoord is D. Okay. Volgende lyk moeilik, so hoop ek kry dit reg. A man jumped from a window of a multi-story building at a certain height above a firefighter safety net. Sorry. Okay. Stage 1 takes 0.3 seconds to reach the mat. Stage 2, the net stretches 1 meter. Before the man comes to rest after 0.2 seconds. So op, en ek neem aan, hy gaan weer op. Ek neem aan, hulle sê nie, eintlik nie. Okay. Which one of the following statements regarding mechanical energy and momentum of the man is true? Mechanical energy. Mechanical energy is die som van die potentiële plus die kinetiese energie. Momentum, mass times velocity. Okay. Stage 1. Stage 1. The mechanical energy and momentum remains constant. Okay, kom ons dink gou. Mechanical energy is die som van die twee. Here, the kinetic energy was 0, maar die potentiële energie is by sy maximum. And here, or wherever he stops, the kinetic energy just before he stops is at a maximum, and the potential energy is 0. So hulle kanselleer mekaar uit. So yes, the mechanical energy does remain constant. But the momentum, wag, stage 1 hier is daar nie. Net tot daar, okay? But the momentum has to do with the velocity. He saw a velocity 0, he saw a velocity at a maximum. So it does not remain constant. Okay, so kom ons check gou. Mechanical energy remains constant, momentum changes. Mechanical energy remains constant, momentum changes. So it's either C or D. Nee? Okay, kom ons kyk gou by stage 2. Stage 2. Nou moet ek net gemoed dink, ek weet nie waar hy eindig nie. Do you guys think he ends here at the bottom? Think you so? Gaan hy nie? Nee, want hy hop nie weer op nie. Hulle sê hy sak af en dan kom hy tot rus. Okay.
Hy gaan verby daar meter, maar weer op 'n meter.
Nee, hy gaan nie weer op 'n meter nie.
Nee, maar so hy sak mos 'n meter af, so hy moet sak en ons optrek en weer met presies waar jy was, wat kan weer op waar uit.
Nee, maar ek dink gaan as jy op 'n trampolien lê, dan buig hy so 'n bietjie af. So hy gaan nie weer terug op nie. Dis wat my kop vir my sê. Dis hoekom ek lees dit ek sê, okay. Kom ons lees ons sê. The net stretches 1 meter on impact before the man comes to rest. So ons neem aan hy kom ter daaronder and he stays down there. Okay. So kom ons dink gou. Here at the beginning the velocity is at a maximum. Here the velocity is 0. So does the momentum remain constant? Nee, the momentum change. Momentum change. Momentum change. Okay, so it's of B, maar ons weet dit is nie B nie. So of C of D. So it has to do with mechanical energy. Okay, kom ons dink aan mechanical energy. The height here is maximum. And the height here is 0. The velocity here is maximum. The velocity here is 0. So bly dit dieselfde, kanselleer hulle mekaar uit? Nee, they do not remain the same. So the mechanical energy does change. So ek sal sê die antwoord is D. Kom ons kyk gou heel agter, wat se vraag is hierdie? Hoe is die memo nie hier in nie?
Hy het nie meer nie.
Kijk, zullen we naar les zien. September 2008. Oké. Kom eens kijken, vraag 4. The engine of a car does work. Okay, so the engine werkt. Gaat hy. To increase the velocity of the car from 0 to v. So hy begin uit rus en dan hy snelheid van v. The work done by the engine to increase the velocity from v to 2v is. Work done by the engine. The work done by the engine. So the net work done, en ons neem aan daar's nou net die engine, is the change in kinetic energy. Hoekom het ek soontoe gegaan? Want hulle praat van velocity. Okay? What is change in kinetic energy? RV final squared minus a half V initial squared. Okay. Nou, die eerste scenario, the first scenario from 0 to V was W. Okay, so kom ons check net gou vinnig. So dit is hoe gaan ek sê so? A half mv squared. Okay, want die final velocity was v, so v minus 0, so ek gaan net sê minus 0 nie. Is julle met my? Is gelijk aan W. That's what they said. At the beginning, to go from 0 to V, it's W. That's the first one. The second one, okay, we have, is a half m. Now the final velocity is 2v. So now is it 2v squared. Minus, en dan is net v squared, so a half mv squared. Okay? So jy kan om hierdie nou, ek kan dink aan 2 maniere om te doen. I'm just gonna multiply that 2 in there, then it's 4. So then I have 4 a half mv squared minus a half mv squared. Okay. En ek weet hierdie, this is the same as w, selfs as v. So I basically have 4v minus v. Not v, w. W. Okay, maak seker is met my. Daai is dieselfde as daai, which is W. Daai is W. So dit gee vir jou 3W. So the answer is C. Okay. Formules. Doppler effek. Okay. Die sirene van 'n polisiekar wat teen 'n spoed V beweeg emits a wave frequency of F. Which one of the following best describe the frequency that will be observed by a passenger in a car following right behind the police car at a speed of V? Okay, goed. Wat is die Doppler effek? Wat is die definisie?
Die verskil word waarskynlik nou die verskil maak van die klankgeluid soos dat ek weer aan die verandering van die geluidsaal en klank die snelheid.
Okay. En nou gaan leer iemand anders probeer? Doppler effek? Nee, not directly. Due to the change in verandering in snelheid, motion, movement. Joh, julle, waar is jou definisie? Wat ek nog nie met dit. Lekker ander goed gehad hierso. Kyk. Yeah, so the primary frequency of the observed sound, because the source and the sound have different velocities relative to the medium. Different velocities. Het hulle die verskillende snelhede? Do they have different velocities? No, they do not have different velocities. Hulle beweeg, hulle sê vir jou, you have a police car, you have a car, and the car is moving with the same velocity as the police car. As hulle verskillende snelhede beweeg, if the car is moving, police car is moving, and the car passed it, dan het hy verskillende snelhede, and it has different velocities. Then you'll hear something else. If they moved away from each other, different velocities because it's different directions. Okay? Maar because they're moving at the same velocity, omdat V and V, then it will hear the same frequency. Selfde frequency. Kyk, volgende ene. A listener moves at a constant velocity towards a stationary source. Stilstaande bron. The frequency of the sound heard by the listener is higher than the frequency of the sound emitted by the source because. Okay, so I hoor 'n word. What's the frequency heard is higher. Hoekom is dit hoër? Want die golwe word saamgedruk. The waves are compressed. When waves are compressed, they are closer together. So die golflengtes is kleiner. So the wavelength observed by the listener becomes shorter. Yes, sharp. Become shorter. More wavefronts reach the listener per second. Ek wil sê ek sal dit ook aanvaar. Dit beweeg teen dieselfde kant. Wag net gou. No, it's near. Dit is the wavelength becomes shorter because they are compressed. Because frequency is inversely proportional to wavelength. Okay. Kom ons kyk sommer na die volgende een ook. The pressure versus time graph below represents a sound wave emitted by a stationary source. Daar gaan hy. Which one of the following graphs best represent the sound wave as observed by a stationary observer if the source is moving towards the observer? Okay, nou om toe, wat gebeur? Golwe word saamgedruk. Okay, so golwe word saamgedruk, so wat se een maak vir my sin daarso? Obviously A. Okay. Goed, so is nie te moeilik nie. Kan julle sien dat die klank, so the amplitude is dieselfde. Okay, so hy het nie om harder gesit nie, hy het net om saam gedruk. Okay, so A. Okay, wil julle nog ene doen? Ek voel dit was nog nie te moeilikie. Ja. A source of sound approaches a stationary listener in a straight line at a constant velocity. Okay. Luisteraar staan stil, klankbron beweeg na hom toe. Teen 'n konstante snelheid. It passes the listener and moves away from him in the same straight line at the same constant velocity. So, which one of the following graphs best represent the change in observed frequency against time? Okay, so daai frekwensie, as hy na hom toe kom, if it comes closer, it is higher, né? En as hy wegbeweeg, it goes away, it is lower. So my kop sê dadelik vir my, higher, lower. So of A of C. Okay, so dit kan nie B of D wees nie, want dit is laer en dan hoër. Okay. Nou, sorry. Hierdie frekwensie, okay, we never, wanneer ons 'n sommetjie doen, frequency listener is do we have in their distance, afstand? Nee, nêrens sê is, okay, maar hierso is die frekwensie wat hy hoor 10, hierso is dit 20, hierso is dit 30. We don't say that. We say if it approaches at a certain velocity, it is 60, and if it goes away at a certain velocity, it is 20. Ons sê nie, hoe verder hy is, the further it is, the change in velocity. Okay, so dis hoekom dit nie C is nie. That is why it's not C, because C says the velocity gets more and more the closer you get near. We just say if you come closer, it is higher, and if you go away, it is lower. Okay, so die antwoord is A. Okay. Consider two spectrum diagrams. Diagram 1 represents the spectrum of an element in a laboratory on Earth. So dit beteken of an element. Okay, so beteken sê maar dit is nou suurstof wat ons het. Okay? So suurstof, they put the oxygen gas in, they put light through it, and they see it gives you a bluish and a greenish and a orangey color. Dit is suurstof. Now they observe, or they have oxygen in space somewhere, same element, oxygen in space of a distant star, is observed from Earth. Okay, so ons nou weer die suurstof, we know it's oxygen, maar hy lyk nou 'n bietjie anders. Looks a bit different. Okay, you can see it's the same lines, but now they're all just moved a bit to the right, a bit to the red side. So we say it's a red shift. Want al die lyne net regs geskuif, rooi geskuif. Okay, what does a red shift mean? It means the object is moving away. Okay, so the star is moving towards Earth. Nee. The star is at rest. Nee, want as hy in rus was, if it was at rest, the spectrum lines would have been exactly the same. Want hy beweeg nie. And the star is moving away from Earth. Yes, see. Okay. Electrostatics. Two identical metal spheres on insulated stands carry charges Q and Q respectively, as indicated in the diagram. When they are a distance r from each other, they experience force F. Okay. The two charges are now moved closer to each other so that the final distance between them is half the original distance. Which one of the following correctly describes the new magnitude, die nuwe grootte van die krag tussen die ladings? Okay, I'm going to give you 20 seconds. Jo, dit is nou 'n minuut. Tawana? Which one? You think correctly, it is D. Jo, presies dieselfde vraag, kom ons kyk of daar nie 'n ander vraag is, nie? Dis 'n vreemde vraag. Kom ons doen maar 'n vreemde vraag. Maar ek dink dit is te maklik. A negatively charged plastic cone, so a kam, is brought close to but does not touch a small piece of paper. If the comb and the paper are now attracted to each other, the original charge on the paper was what? So, negatiewe kam, papier. Kom naby. Trek mekaar aan. Wat is jou eerste gedagte vir jou? Positief en negatief trek mekaar aan. So dan moet 'n stukkie papier positief wees. Maar, but, a big fat but. It can also be neutral. Dit kan ook neutraal wees, want ek kan nie eens onthou of ek dit met julle gedoen het in graad
Ek wil ook vra, want ek sê pas moet ook neutraal.
Het ek die experiment met julle gedoen met die water en die liniaal? Nee?
Want dan die halwe doen met papier en dan geskryf en papier.
Dan maak jy so. En dan ek weer 'n goeie rokkie aan die vandag. Trek kan jy nou sien dat hy aantrek of nie? Nee, dat kan nie sien nie, nee. Okay, so wat ek nou doen, dit hang af waarvan die hele nie al gemaak is. If it will become negative or positive, I think a ruler becomes negatively charged. Okay, sien dit aantrek of nie?
Ja, ek sien dit ja.
Okay.
Weer baie lief.
Ja, ek het nou nie genoeg dit gedoen nie. En omdat dit gister gereën het, is daar baie moist in die lug. So dan gaan nie so goed werk. Maar so the water is not negative or positive, it's neutral. Maar wat gebeur as jy dit nader bring?
Hy elektron word oorgedra.
As hy raak word oorgedra. As jy net nader bring, dan is daar polarization wat gebeur. So the electrons in the ruler repels the electrons in the water, hulle beweeg aan die kant toe en hy trek die protone aan. Hy trek die protons. So as 'n aantrekking is, and you don't know what's the other one, then it can either be neutral or positive. Dis hoekom die antwoord D is. Hoi.
Ja, ek het gehad met dit was gehad het wat dan hang net, maar dit is neutraal en dan onder was negatief. Dus hy plus 32 as jy uitgewerk het.
Okay, kom ons kyk. Kom ons kyk hier 10. Two small identical metal spheres, each carrying equal charges Q, are brought into contact and then separated. The charge on each sphere now will be what? Two small identical spheres, each carrying a charge of Q, are brought into contact and then separated. Kom ons sê Q is 10. Nee? Then we have 10 plus 10 divided by 2. What does that give you? And for this here. I think all of our initial reactions was a half Q. Nee, was jy nou makkie? Slimmie. Okay. Ja. Okay. Kom ons kyk gou D. Two charges, so dis vraag 13. Two charges plus 2 nanocoulomb and negative 2 nanocoulomb are located on a straight line. S and T are 2 points that lie on the same straight line as shown in the diagram. Which one of the following correctly represents the direction of the resultant electric fields at S and at T? Okay. Hulle is 2 punte, positief en positief. Nee? Okay. Kom ons kyk gou na S. Ag tog. S. So S. Negative, positive, what do they do? Attract. And positive and positive repel. Okay, so here's the direction of the resultant electric field at point S is to the right. So it's this one or this one. Nee? At T, kom ons kyk hierso, positive and negative attract. Positive and positive repel. Ooh, canceleer hulle mekaar uit. Do they cancel out? No, because this distance is a lot bigger than this distance. So it means this force to the left, so this positive and negative, this force to the left is a lot bigger than to the right. So this net force will be to the left. Left, left. So die antwoord is A. Okay, is julle sharp? Dink ons nou genoeg gedoen van hulle almal. Kom ons doen sommer hulle twee, hulle almal lyk lekker. Two charges, plus Q, negative Q, or plus and distance to D, negative Q, la. Okay, goed. So prentjies soos wat ons nou gehad het. Okay? Positief, negatief, positief. Negatief, ekskuus. Which one of the following arrows correctly shows the direction of the net force acting on negative Q due to those two? Okay, let's check. Negative, positive, wat doen hulle met mekaar? Attract. Negative, negative, what do they do? Repel, so hy gaan daai rigting. So waar gaan die netto krag wees? Daar. C. Okay. Ek was nog hierin ook. Two charged particles are placed at a distance R apart. The electrostatic force experienced by one charged particle on another is Fe. Which one of the graphs correctly represents the relationship between the force and the square distance between the two charges? Wat sê Newton se, Newton nie, the electrostatic, the Coulomb's law? Force is directly proportional to the product of the charges, and the force is inversely proportional to the distance between them squared. Inversely proportional is what shape? B. Inversely proportional. Sharp, sharp. Okay, kom ons kyk. Ek het vergeet, er is nog 'n paar hoofstukke oor hierso. Hierso is stroombane. A battery with, ja?
Wat iets met motors of verlig of ja.
Ons kom nog daar. Ja. A battery with MFE and internal resistance R is connected to a resistor R as shown in the circuit below. Okay. Jy sien daar, there is one resistor, een weerstand, ammeter, voltmeter. Marie, fokus jy nog? Jy jok. A second resistor of the same resistance is now connected in parallel. Okay, so nou het ons blokkie, ammeter, die hele battery besigheid. Okay. How will the voltmeter and the ammeter readings change when the second resistor is connected in the circuit? Okay. Goed, nou hierdie is 'n baie goeie vraag wat jy gister gevra het. Wanneer jy so iets kry, you have something and there's internal resistance, you can't just say easy peasy. Okay, dit werk nie so nie. Jy gaan moet vir jouself 4 stappies vra. Stappie nommer 1, question number 1 is what happened to the total resistance? Wat het gebeur? When you added 1 in parallel. Totale weerstand het afgeneem, né? It decreased want dis 1 over RP blah blah. Total resistance decreased. So then your second question is what happened to the total current? If the total resistance decreased, wat het met die totale stroom gebeur? Increased. Okay. So there you have half of your answer. What happened to the ammeter reading? Wat mees die ammeter? Hy mees die totale stroom. So the ammeter reading increased or increased. Dit is een van daai twee. Goed. Dan vra jy vir jouself, okay, what happened to the last volts, of die ander naam vir hom is volts internal. Hoe bereken ek nou weer dit? Dis die stroom maal klein r. Did small r change? No. het die stroom verander. Ja. So the current increased, die stroom het toegeneem. Klein r het dieselfde gebly, so wat het met hierdie hele ding gebeur? Toegeneem, increased. Okay? So now we can look at what happened to volts external. Volts external is daai ene. Hy kon hier ook gewees het, it could have been there as well. Maak saakie. Okay, en vir dit gaan ons kyk na hierdie formule. Gaan sê volts external plus volts internal. Daai IR plus R besigheid. EMF, did that EMF change? No, it stayed the same. What happened to volts internal? It increased. So what happened to volts external? Decreased. Okay, so volts external decreased, so the voltmeter reading decreased, so die antwoord is C. Okay, jy kan eintlik vir altyd nou dit so dink. If that increased, that increased, that decreased. Altyd. So if the current increased, the volts external decreased. Always. Okay. En nog 'n stroombaan. A variable resistor, an ammeter, a battery of EMF 12 and a voltmeter are connected as shown. Okay, sharp. You can see there, that is the rheostat wat ek vir jou gister gewys het. Daar is 'n voltmeter oor die switch. When the switch is open, the readings on voltmeter V1 and V2 will be respectively what? Okay. V1 sal wees 0. Okay, want dis oop, so die battery gee niks nie, hy neem niks nie, niks. Okay, but the voltmeter reading over the switch will give you something. Want die mannetjies wat hier is, the men that are trapped inside there, they have, kom ons sê dis nou 12 volts. They have 12 volts here. They can't go anywhere. Hulle kan nie teruggaan in die huis nie, hulle kan ook nie deur gaan skool toe nie. And the little men that's here, okay, have already used their energy, their volts. So hulle het 0 volts. So whenever you have an open switch, 'n oop skakelaar en hulle vra vir die voltmeter oor hom, dan gaan dit die maximum volts wees wat dit kan wees, 12 volts. So die antwoord daar is D. Okay. Ons tyd is min, besef ek. Okay, so terug gaan na as ons kan. Okay. Stroombane. So. The simplified diagram of an electric motor is shown. Okay. So electric motor, dit sê jy begin met elektrisiteit, you start with electricity and it produce a motion. Okay, en jy sien 'n splittering kommutator wat vir jou sê direct current, né? Gelykstroom. Right, when the switch is closed, the coil ABCD rotates. Okay, almal doen dit op hulle eie. Which hand? Links, because you start with electricity. Easy peasy, left hand. Okay, and onthou, you must choose a section. Kies 'n gedeelte. A, B, C, D, whatever. Choose a section.
Elektronen is 'n battery van positief na negatief. Dis van negatief.
Positief na negatief.
Dis van positief na negatief.
Positief na negatief. Wat jy gedoen? Wat het jy gekry? Okay, you'll get anti-clockwise because it's north to south. I look at section AB, so AB daar in, current in there, so AB is pushed downwards, so I rotate anti-clockwise. Okay. Anti-clockwise. Okay, which one of the following changes to the design of an AC generator will increase its maximum EMF? So wat sien gaan maak dat hy 'n groter walts kry? Generator begin mos, you start with mechanical energy and then produce electrical energy, né? So, you start with rotation. So, either more rotation, meer beweging, or stronger magnets, né? Or more coils, more turns, meer windings of spoele. You can't say a bigger current because you produce the current. You don't start with the current. So, change the polarity. Nee, dit gaan net maak dat hy nou andersom draai. Use larger slip rings. Nee, slip rings is maar net die kontakpunte. Use larger brushes. Nee, increase the number of turns. Yes. Okay. Kom kyk gou daai vraag 11. Graph P represents the output EMF of an AC generator. Q is the output EMF after changes has been made using the same generator. Okay, kom ons kyk gou. So it is P. Right. How is Q different? It's different in two ways. Number one, hierdie is net een golf and this one is two waves. So hy gaan vinniger, né? En wat jy kan sien daarso is P is a lot higher. So dit beteken sy volts is ook meer. Okay. Goed, so let's say which one of the following changes has been made to the generator? The number of turns of the coils has been doubled. The surface area has been doubled. The oppervlakte is vergroot. The speed of the rotation has been doubled. The strength of the magnetic field has been doubled. What's in Angela? See, yeah. See, because we see it is faster as well. It's vinniger ook. As dit nie vinniger was nie, if it was not faster than die ander coil.
Dit is goed vir dit ek my 2 keer so lank gevat het. Ek kan by 2 uit in een versheid uit 2 keer.
Ja, so dat tyd het
dit.
Ja. Okay, kom ons kyk gou na lig toe. Okay. The energy level diagram for an element is shown. E0 is die grondtoestand, the ground state. The energy change from E0 to E1 is smaller than that of E1 to E2. Okay, so this is in die prentjie gesien. The electron transition from E2 to E1 corresponds with a green line. Okay, groen lig in an element spectrum. The transition to E to 0 corresponds to what? Okay, so let's say if you hierdie ene kleiner energie as daai ene. This one is a higher energy, more energy. Green is more to the bluish side, yes? And blue is high energy. So this one can't be blue, it can't be purple, it kan nie groen wees nie. It must be a lower energy. Rooi, of so ietsie. Okay. Okay, so it says there, the transition from daai to daai corresponds with, is dit sê green light, as hy nou net gesê, dit kan nie hy wees, it can't be green light. Nou sê hulle vir jou, the emission of red light or the absorption of red light. Okay, so rooi lig maak vir sin, because it's lower energy. Okay, emission or absorption. Wanneer die lig inkom, when the light comes in, and the electron jumps up, then how can it jump up if it takes in the energy? As hy die energie inneem, dan kan hy opspring. Okay, so that is absorption. So to go up is absorption. When it goes down, it gives away that energy, then it is emission. Okay, so jy kan sien hier, die pijltjie gaan op, so dit is absorption of red light. Die. Okay, laaste vraag. Kom ons kyk gou, is hierdie 'n goeie vraag? Nee. Ja, sal dit 'n vraag. Okay. Wat is dit nou? Hierso. A metal is illuminated with a light of frequency F and the electrons emitted have a maximum kinetic energy E. Which one of the following graphs best illustrates the relationship between kinetic energy of the emitted electrons and the frequency of the incident light? En dit is wat Juan ook gister gevra het. Waar is gesê, if you increase the frequency, die frekwensie meer maak, wat beteken dit? Dit beteken jy maak die energie meer. You increase the energy. Want, hy beweeg nou vinniger. Hierso beweeg hy stadiger. So, if you increase the frequency, it means you give it more energy. So, they are directly proportional to one another. Hulle is direk evenredig aan mekaar. En daarom is die antwoord B. B of D? Hoekom wil ek sê liewers D?
Want ek moet die energie kry voor ek kan afsluit by jou.
Somewhere we have the threshold frequency, die druppel frequency. So die antwoord is D, nie B nie. Okay, dankie julle.